Hey guys, welcome again to the Maths Club. If you're just joining us, welcome. So we finished the series on number bases. You can check that at the point that will appear at the top right. And now we are starting the next concept in the mathematics WAEC syllabus, which is modular arithmetic. Yeah. So as always, there are some objectives that WAEC would like you to know. I mean, that is the essence of the syllabus that is set. So in this particular concept, we're going to be talking about how to interpret modular arithmetic, right? How do we add, how do we subtract, how do we multiply in modular arithmetic, right? And also talk about the application, right? The application of modular arithmetic. Now, before we explain what is modular arithmetic, let me give you an insight into what an application of modular arithmetic is. Let's come from the application point. So when you see the clock, right, you have values from 12 a.m. right to 12 p.m. What happens is that when you start off the day, at 12 a.m. right, and it keeps on going until you reach 11 a.m. right, then you come again to 12 p.m. right. What happens after 12 p.m.? You continue again. You don't start from 13 p.m. except you are working in like 24-hour format, right? So what will relatively happen is that after you reach 12 p.m. right, it starts again from 1 p.m. So you can see it's wrapping around this same value. You can see you're just going in a cyclic order, right? So after 12 is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. After 12 again is another 1, 2, 3, 4, 5, 6. It's just wrapping around values from 1 to 12, right? That's the idea behind modular arithmetic, right? To find yourself going around in circles, right? So now that we have a bit of understanding of what modular arithmetic is, let's look at the theory behind it. So it says modular arithmetic is a mathematical system. So it deals with integers. Integers are numbers like 1, 2, 3, 4, minus 1, minus 2, minus 3, right? And their remainders when divided by a fixed number called the modulus. So let's see. Put it so let's say we are looking at this clock, right? At this clock, right? So if somebody was counting, right, and he said, "Oh, the time is 1500, right? 1500, right?" And you want to calculate, you want to say 1500. I mean, what is 1500? How do you know what 1500 is relating to that our normal clock image? What do? You know that the clock actually wraps around when it reaches 12, right? When it reaches 12, it goes again to 1, 2, 3, right? Just divide that 15 that you have by what is wrapping around, which is in this case 12, right? If you divide 15 by 12, what will you have? You have one whole number, right? With a remainder of what? With a remainder of 3, right? That is why you see it is what? 3 p.m. if you relate it to that clock. What am I trying to say? Whenever you have a value, right, and then you want to find let's say there's a modulus involved, right? Just like in the clock, right? The modulus of the clock is 12, right? Because when it reaches 12, it wraps around again. It goes again to 1, 2, 3. It doesn't continue 13, 14. It goes again to 1, 2, 3, 4, right? Divide that value by the modulus, right? The remainder that you get is the representation in the clock, right? So if I know that someone tells me that it's 1500, I know that 1500 is going to be what? It's going to be 3 p.m. right? If a person tells me that it's going to be 1600, I know 1600 is going to be what? It's going to be 4 p.m. because 16 divided by 12 is 1, the remainder of 4, right? So let's go back to the distance. So it says it deals with integers and their remainders. In this case, the integer here is 15, right? The integer here is this 15, and their remainders. The remainders here is this 3, right? When divided by a fixed number called the what? The modulus. The modulus here is what? Is 12, right? So you can imagine that. So even if I had 1700 and I wanted to convert it to our clock time, I'll say 17 divided by what? Divided by the same 12, right? Which will be 1 remainder 5, right? The same 12. So you can see that there is a what? There is a fixed value by a fixed value, which is the modulus. And we can see it says numbers wrap around after reaching a certain value. Does that make sense? So the numbers keep on wrapping around after they reach a certain value. Great. So we've talked about the application with this clock, right? Let's look at an example. So look at this now. So if the time is 700 now, right? Then 8 hours later it will be. Do you want to pause the video and try it out? Welcome back. Right? There are two ways that we can actually do this. We can actually say, oh, 7, right? 7 o'clock. Let's go to our clock and do 8 hours later. That will be 1, 2, 3, 4, 5, 6, 7, 8. Right? So we say, oh, 8 hours later it will be what? It will be 3 p.m. But is that effective? That's not effective. That's not effective. So what can we do? What can we do? We know that the time that we are in now is what? 7 a.m. Right? If I had 8 hours to this 7 a.m., this would be 8 hours, right? That would give me what? 1500, right? 1500, right? And then that the clock has a modulus of 12. I can just say 15 divided by 12, right? And that will be 1 with a remainder of what? Of 3. Of course, I know that I'll just pick the remainder value. So I know that if I had 8 hours to 7 o'clock, right, it will take me to what? To 3 p.m. right? And that is the exact same thing. So instead of us counting, we achieved the same thing just by adding 8 hours to the initial value that we had and then dividing by the modulus number, which is 12. The remainder is the value represented in that circle. Great. So the answer is going to be 3 p.m. Great. Another application that we see of modular arithmetic is in calendar calculation. What do I mean? Look at something. You notice that a calendar wraps around Sunday, right? So if it starts from Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. After it reaches Saturday again, it goes again to what? To Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, right? You can see the calendar wraps around Sunday to Saturday. So if our Sunday is our first day, Monday is our second day, Tuesday is our third day, Wednesday is our fourth day, this is our fifth day, right? Our sixth day, and then our seventh day, right? So if a question comes and says, oh, today is Wednesday, right? In 15 days time, what day will it be? Right? I already know that my Wednesday is the fourth day, right? So I could just say Wednesday, which is what? 4 plus the amount of days I want to add to it, which is 15, Abi. And I'll divide it by what? How many counts do we have? We have 7 counts. 7 counts. So that means it wraps around with the modulus of 7. Because this is 1, 2, 3, 4, 5, 6, 7, right? Divided by 7, right? 4 plus 15 is 19, Abi. 19 divided by 7 is actually what? 2 with a remainder of 5. So 5, that means that it will be on day 5. And day 5 is what? Thursday. Does that make sense? So you can see the application here. So I mean, it's very, you don't have to disturb yourself, because you know that it's going to keep on wrapping around. Just add the number of days and divide it by the modulus, this case, which is 7. The remainder would tally with the remainder will now tally with the particular day that is going to be after 15 days. Great. So let's go. So the next concept we're going to talk about is congruence, right? Given an integer n which is greater than 1, call the modulus. Two integers a and b are said to be congruent modulo n if n is a divisor of their difference. Hold on with the English. So let's move further. It says congruence modulo n is noted as a with a triple equal to sign b mod n, right? Now, how can we relate it to what we already know? Because there's a lot of English. We know already that the n is the modulo. So if we use our example here, so this is our n, right? The n is the modulo, right? In this example, because modulus was 12, right? The a, right, would be the value that we are dividing by the modulus, which is this one, right? And then the b, right, would be the what? Would be the remainder. Note it. A is the value that we're dividing by the modulo, and the modulo is the n, right? The b is the what? Is the remainder. Remember, in this thing here, the part that really matter is what we are dividing by, and what is the remainder. So a is the what we are dividing, b is the results, and n is the modulo. So let's go and explain. So it's given an integer n greater than 1. N is our n in this case. Is it greater than 1? Yes, 12. Call the modulus. Two integers a and b, right? 15 and 3 are said to be congruent modulo n, modulo 12, if n is a divisor of their difference, right? So let's see. If we have a to be 15, right, and we have b to be 3. If I do a minus b, what would that give me? 15 minus 3, which is equal to what? Which is equal to 12, right? It says something. They said two integers a and b are said to be congruent modulo n if n is a divisor of their difference. Our n is 12 and the difference is 12. Can 12 divide 12? Yes, it can divide 12, right? That will give us 1, right? So because it can divide, right, we can say that a and b are said to be congruent modulo n. Why? Because the n, right, is a divisor of their difference. So, but if I had something like maybe 16 minus 3. 16 minus 3 is 13, right? Can 13 divide 12? No, right? 13 cannot divide 12 like without a remainder, right? So in that case, it's not pass this condition. Now, how can we be able to represent it? How do we represent it? So now that we know that our condition holds true, right, we can now say that what? So our a is 12, our b is 3, our n, so our a is actually 15, not 12. Our n is the one that is 12. Our a is 15. Let me correct that. So our a is 15, our b is 3, and our n is 12. So how can I represent it in this particular place? Right, I'll say 15, right, is congruent to what? To 3 mod 12. Right, this is actually it. Right, so basically saying that your value that you have, right, is congruent to the remainder, right, in bracket of the what? Of the mode they are working in. Right, so that's actually everything about this congruence. Right, so if you read it again, you'll see it. Now, so from our earlier example, we could say that 15 is congruent to 3 mod 12. Right, so that is basically it about the congruence. Once you can be able to find the remainder, right, just put it in this format in terms of congruence. So this is 15, right? 15 is congruent to 3 mod what? Mod 12, right? And that's it. So with that, we've actually come to the end of the introduction to modular arithmetic, right? By the time we come to the next video, we'll be talking more on the addition, the subtraction, and then the multiplication, right? And then we'll deal with WAEC past questions that contain modular arithmetic. If you found this video useful, please like the video, subscribe to our channel so that you can be updated with regular contents that we churn out. If you have any comments, please put it out in the comment section. I would address all comments and see you guys in the next video.